Today, we're going to try something really cool. We're going to build an artificial intelligence and teach it to predict the future. Now, we're not talking stock prices or anything like that. We're starting with something we all know, something we feel every single day, the weather.
And that really gets to the heart of it, doesn't it? Can a machine actually learn to see what's coming? Well, to find out, we're not just going to talk about it. We're going to build one, right here, right now, and see if it can make sense of something as chaotic as the climate.
All right, let's jump in. Our mission, our quest, is really straightforward. We're taking a whole bunch of historical weather data from Delhi, India, and we're going to use it to train our AI to predict tomorrow's temperature. Simple as that.
Now, every good story needs a hero, and every hero needs a source of power. For our AI, this table is it. This is our raw data. We've got 4 key clues for it to work with: the average temperature, the humidity, the wind speed, and the air pressure. These are the puzzle pieces our AI is going to learn to put together.
But you can't just dump all this raw information into an AI and expect magic, right? Raw data is kind of like raw ingredients for a recipe. You gotta prep it first. We need to turn this data into high-octane fuel for our model.
So here's the game plan. It's a 3-step process. First up, we're gonna scale everything, basically putting all the different measurements on a level playing field. Then we sequence it, chopping the data into 30-day chunks. And finally, we split it. We'll use most of it for training and keep a little bit aside for a final test.
And check this out. This is what that scaling actually does. See how a mean pressure of over 1,000 becomes just 0.13? We're just squishing all the numbers to fit between 0 and 1. Why? Well, it's super important because it stops one measurement, like air pressure, from shouting louder than the others, like wind speed. This way, the AI can listen to all of them equally.
So this is the core of our strategy. We're teaching our model one very specific skill. It's going to look at a 30-day chunk of weather, all 4 of those features, and its one and only job is to guess the temperature for the very next day, day 31.
All right, our fuel is prepped. Now it's time to build the engine, or, in this case, the AI's brain. This is where all the thinking, all the learning is actually going to happen.
Now, we're not using just any old neural network. We're using something special, called a Gated Recurrent Unit, or GRU for short. And the best way to think about a GRU is that it has a superpower: memory. It's specifically designed to spot and remember patterns over time, which, is perfect for something like weather forecasting.
So let's pop the hood and see what this grain is made of. It takes in our 4 weather features, that's the input. It has a hidden dimension of 64. Think of that as its short-term memory. We're stacking 2 of these layers on top of each other so we can learn even trickier patterns. And what comes out the other end? Just one number, our temperature prediction.
And now for my favorite part, the training montage. This is where our AI puts in the hard work, learning from all that data, getting smarter and smarter with every pass. Cue the 80s music.
We're going to put it through its paces for 200 epochs. So what's an epoch? Well, think of it like reading a textbook. One epoch means it reads through the entire history of our weather data one time. So we're making it study that history book 200 times over. It better learn something.
And wow, just look at this learning curve. This is incredible. This graph shows how many mistakes the model is making over time. See that massive nosedive at the very beginning? That's the aha moment. You can literally see the AI starting to get it, as its predictions get way more accurate right off the bat. Let's put some numbers to that. After only 5 training runs, its error rate is already teeny tiny. By the 100th run, it's even smaller. And by the end, at 200 epochs, the error is a minuscule 0.00226. It's not just learning, it's refining its skills, getting better and better with every single pass.
Okay, the training montage is over. Our AI has studied, it has practiced, and now it's time for the final exam. This is the moment of truth.
Remember that 20% of the data we hid away at the start? Well, our model has never, ever seen it. It has no clue what the right answers are. This is the real test. Did it actually learn the patterns of weather, or did it just memorize the answers from the training data? Let's find out.
And the first result is in. The final mean squared error is just 0.00285. Now, I know that's just a number, but what it means is that its guesses were consistently super close to the real temperatures. That is a fantastic result.
And this next metric, the mean absolute error, just hammers that point home. At about 0.04, it tells us that on average, the AI's prediction was only off by a tiny, tiny fraction of a degree. It wasn't just accurate, it was reliable. It wasn't just getting lucky.
But hey, a picture's worth 1,000 numbers, right? Just look at this. The blue line is what the temperature actually was. The orange line, that's our AI's prediction. I mean, it's practically a shadow. It tracks the real weather almost perfectly, catching all the little ups and downs and even the big seasonal shifts. Incredible.
And this really says it all. The whole reason we chose that GRU model was for its special memory, its ability to find those long-term patterns. And as you can see, the numbers don't lie. It worked. Our AI hero absolutely nailed its quest.
So, we did it. We taught a machine to look at the past and predict the future of the weather with amazing accuracy. And that leaves you with a pretty big thought, doesn't it? If we can teach an AI to find the hidden signals in the chaos of the climate, what other complex futures could it help us get ready for? Think about farming, or energy, or even preparing for natural disasters. What else could we see coming?